All right, hey, welcome my math friends to a very short introduction on the remainder theorem, the factor theorem, and how that all relates to using synthetic division and synthetic substitution. So first, this is relating to problems 13 and number 15 in the book. So first, what is the remainder theorem? It simply states, right, if a polynomial function such as p of x, so just imagine in your mind what that could be. That could be like over here. This is a polynomial function, right? 2x cubed minus 3x squared plus 4x. So if something like that, I'm going to come back over here. If that's divided by just a linear expression like x minus c, so the c stands for like a number. It could be like x minus 1 or x minus 2. So if you divide that into the big old polynomial, then the remainder is the same as evaluating that polynomial at c. So in other words, like if I want to divide it by x minus, say, 5, the c would be 5. I could do all that long division stuff that you've done in the first few problems, or you could just take 5, stick it into the polynomial function, replace it for x, do all that math, and whatever the answer you get is the remainder. So it's kind of cool. I mean, some of you, like, you realize this, you've been using it already, but this is an actual theorem in the book that actually will prove why that works. And this is what allows us to even use synthetic substitution in the first place to divide polynomials. It's because of that fact. So that's your remainder theorem. And from the remainder theorem comes the factor theorem, which essentially says the same thing, and it's saying now if you divide x minus c into that polynomial, and after you do all the division, if the remainder turns out to be 0, then that is a factor. So in other words, if you do your synthetic substitution and your synthetic division, you do all that stuff, at the very end you get a 0, then whatever you divided by in the beginning, that is an actual factor of the polynomial. It divides perfectly into that polynomial. So just kind of thinking about it with regular numbers, that's like the difference between dividing 7 into 32, which goes 4 times, but there's a remainder of 4, so 7's not really a factor. It doesn't go into it evenly. It doesn't go into it perfectly. Versus dividing 8 into 32 when there's no remainder. So 8's a factor. It goes into it. 4 times 8 are both factors. When you multiply two factors together, you come back to the regular number. When you multiply non-factors together, you fall short, and you've got to add a remainder to it. So the factor theorem is just telling you that if you did synthetic substitution, you picked a number like 5 or 4, whatever, you stuck it in, you did all the math, and it turned out to be 0, then you know what you started with was a factor. In other words, it's a 0. It's a root. It's an answer to the to where that polynomial function equals 0. So that brings you to 13 and 15. Let me read what it says. It's going to be a little confusing when you first read it, perhaps. The problem says, in questions 13 through 16, use synthetic division and the remainder theorem to evaluate p at c. So here's problem 13. So here's the polynomial function, all that. C is 2. So they want us to evaluate this when we plug the 2 in for the x, right? And just pause for a minute. What does that mean? They're saying c is 2, so x minus c would be like this. So what they're saying is x minus c a factor? That's kind of like what we're getting at. Is x minus c a factor? When we divide it all out, is there going to be a remainder or not? So just keep that in mind, because sometimes the problems are going to be in the format of saying, they won't say c equals 2. They'll say, check x minus 2, and then you need to know whether you put a 2, whether you're dividing by 2 or negative 2. And what you want to remember is, you're always, the format is x minus c. So if they give it to you like that, x minus 2, the minus does not go with that number. So c is just 2. I don't know if that makes sense, but you'll get the hang of this. So in other words, I'm going to start with 2. I'm not going to start with negative 2, right? So I put a 2 here, do my division. Now I put all the coefficients in, 2, negative 3, 4, negative 7. Make sure you check all the x terms. So there's cubed, squared, and 1. So I'm not missing any x's. If I were missing an x, I'd have to put a 0 in there. Don't forget that. and then write your little line, and then bring down the 2. 2 times 2 is 4. That's 1. 2 times 1 is 2. That's 6. 2 times 6 is 12. 12 minus 7 is 5. So there is a remainder. The remainder is 5. It's not 0. So therefore, x minus 2 is not a factor because it did not divide it evenly. And that's all you really have to do for 13 and 15. So I just wanted to give you one example, and you guys try 15 and do 13, of course, on your own. But it's pretty straightforward once you kind of understand what's happening. So good luck and namaste.